In a previous section, we ran into a case where we had a function approaching two different values depending on which side you were looking at it from. So today we're going to address that. The question is basically, what if the function approaches different values depending on the direction? Well, then we can define what are called left and right-hand limits. The left-hand limit is the value that the function approaches as x approaches a from the left side, and we denote it using a negative after the a, after the number. Similarly, a positive represents the value that the function approaches as x approaches a from the right side. So let's take a look at a graphical example. Given this function f of x, it's not really below now, it's above. Answer the following questions. The limit as x approaches 3 from the left side, the limit as x approaches 3 from the right side. All right, well, we can see that from the left side, as x gets closer to 3, we're going toward negative infinity, just graphically. From the right side, looks like we're going up to positive infinity. Now the question is then, which side takes precedence if we are being asked for the limit as x approaches 3? The answer to that is neither. If the two values don't match, then we could say, as we did in the last section, that this limit simply does not exist. So put simply, if the left and right-hand limits are unequal, then the limit at that point does not exist. If the left and right-hand limits are equal, then the limit at that point exists, and the value of the limit is the same as the value of the left and right-hand limits. Meaning, if the limit as x approaches a from the left of f of x equals the limit as x approaches a from the right side of f of x, then the limit as x approaches a of f of x equals the limit as x approaches a from the left, and also the limit as x approaches a from the right. They're all the same.